Let's talk about functions and their use in programming languages, which really provide a means to abstract away from complexity and make code overall a lot cleaner. A question that we could ask is if it wasn't going to be great to think up some functionality, write it, test it, and be able to reuse it at any time in the future. My resounding answer to that is yes, it would be really great to do that because you solve a problem and you hold on to that solution without having to resolve the same problem over and over again. And that really is what programming is about a lot of the time. So what could such a functionality be? It could be download data from a receiver in the field. That can be fairly complex. It might involve strange telemetry connections to get there. It might have to happen at a certain time. It could be that the data as they are stored on the receiver in the field aren't quite in the format that you want. So instead of sitting on a computer and doing all of this manually, if there's a data collection device out in some remote area, you should be able to just run some code day after day that does exactly the same thing. And functions are one way that some of that functionality can be packaged. A function itself is really nothing new if you've taken any math class in your career. Any of the functions you know from those courses takes some input, does something with it, and maps it to some output, f of x, right? So we have input going in, function doing something, and output coming out. I often think of these things as black boxes. And now with programming, you have the capabilities to make these things as powerful and complex as you want, rather than compute the sign of X, download data from receiver Y. And the output could just be a file on your file system of those data, or might even be a plot already. Here's an example where we are linking functions. So here we have an input, x is 3. The function is square x. And then we get an output. And for 3, if we use the value 3, 3 squared is 9. That can be the input to another function, which is x plus 1. Now, that is not this x that's coming in here in the beginning, right? That's a new x. That's the output of the first function that's going to the input. So this is 9 plus 1, and so it's 10. So here we are applying one function on the result of another function. If we do this with 4, right, we have 16. 16 plus 1 is 17. If we do this with 2, we get 2 squared is 4. 4 plus 1 is 5. The beauty here is that you really write all of this just once, and then you can define one input value and get the output for whatever complexity is happening in here. But the thing that I hinted to here in the beginning with this x in here being different from this x in here is really important to keep in mind. Now, we already mentioned that a little bit when we were talking about variables, but there are spaces in which we consider variables. So there's the function f internal variable x here that gets a value assigned on the input side, and then the output is some f of x. And the f of x here is the x that's being defined at the input. Now for g, the new X becomes the output that we used here, or that we have gotten from F. So this really is X or Y or Z or whatever. And then in here, it's X or Y or Z or whatever. It is really important, critically important, that you develop some flexibility in your thinking about variables or variable names, that they have certain areas in which they're being used, and that you can change their names arbitrarily if following the rules of the programming language, obviously, and changing their names in all of the places where they occur. So if we have multiple functions, we can apply them within each other, on top of each other, whichever way we want, without having to write out the equation x squared plus 1 all the time, for instance. So this is the other example here, where we have an input x that first gets converted into an input z, which is x cubed here, and then that goes into a function g, and this now becomes the output g of z, and we don't know what g is actually doing to this input. All we know is that our original user given x gets cubed, and then g does something with it, and eventually we have some output f of x. So this is another layer of complexity where inside of your functions, you can use other functions that the user might not even be aware of. All the user wants to know is, give me the value that you promise by your documentation and your function name. So in Python, for instance, we can open file names, or we can read lines from a file, and you don't need to necessarily know how internally Python is reading character after character in each line to give you the next line in a file. All you care about is the promise that the function gives you, that the next line that you receive is indeed the next line in the file that you're trying to read and analyze. So with that, a function really becomes a set of rules that takes input and generates some output. And the output can be anything, really. It can be a file on the file system, it can be a plot, which is also a file on the file system. It can be a value that you need to consume, or it can be some other sort of message that's being sent somewhere. Some functions may not generate any output. Their output may just be that they do the thing they promise. To connect this back to the class a little bit more, a function really becomes one of the boxes that you drew in the flowcharts. It's one of the most important tools that you have to capture, contain, test, and reuse algorithms and behavior of any complexity. I like to repeat that because it is important that we want to think really hard about solving a problem and then writing down the solution and stashing it away for future use, and not have to solve the same problem again and again. It's a waste of our time. So in terms of the flowcharts, one might be work on the examples, right? So you could envision a function that goes to GitHub and downloads the examples and inserts or opens them one after the other in Jupyter Lab for you, and then you can use them. Or it could be provide feedback, which might be some kind of process that is connected to an email program and asks you for what your feedback is, and then just sends it to the TA and the instructor. Important here is that you capture and contain some functionality. And that means that when you need to change that functionality, you only have to change it in one single spot rather than everywhere in your source code. So you don't want to copy and paste in programming. You want to, kind of develop the solution to your problem in some way, shape, or form, test it, and then retain it in some usable manner. And functions are a great tool for that.